Welcome everyone. In this video I will talk about Poisson distribution. I already have uploaded videos related to binomial, negative binomial and geometric distribution. So in case if you have not seen, you can see those videos as well. I will put them in the link below. Right? So let's start. First of all, the Poisson distribution can be taken as a limiting case of binomial distribution under the following conditions, and this is important. Sometimes they ask questions directly based on this. So the first condition is that n, the number of trials, is indefinitely large, means n tends towards infinity. Second condition is P, the constant probability of success for each trial is indefinitely small, means P tends to 0. And the third condition is NP, which is n into P, that we define as lambda, and this is known as the mean of the distribution. This should be finite. Now when we talk about problem solving in this situation, if number of trials is usually more than 30, we consider them that the large number of trials have happened, right? So proceeding forward, let's understand that what is the Poisson distribution. So a random variable x is said to follow Poisson distribution if it assumes only non-negative values and its probability mass function is given by e to the power minus lambda, lambda to the power x by factorial x, right? Here this x can take value from 0 to infinity, and this is important to remember. If you remember, when I was discussing about binomial distribution, I told you that if there are n number of trials, then the number of success can take value from 0 to n. But here what we are considering that the x, the random variable capital X, can take value from 0 to infinity, and I will explain through different situations, right? This lambda is known as the parameter of this distribution, because only thing that we need to find the probability is the lambda, because once we know the lambda, we can calculate the probability for any number of any value of x is equal to x, right? If I talk about the mean and variance of Poisson distribution, the mean of the Poisson distribution, which I have just defined, is given by n into p, and it is equal to lambda, and variance is also lambda. So this is an important characteristic of Poisson distribution, that mean and variance both are same. In the next video, when I will be discussing about moment generating function, I will help you to understand that how can we generate mean and variance with the help of moment generating function, right? So I am proceeding further now. So let us look at this remark that Poisson distribution occurs when there are events which do not occur as a outcome of definite number of trials, unlike that in binomial distribution, right? So in this, let me repeat that Poisson distribution occurs when there are events which do not occur as a outcome of definite number of trials of an experiment, but which occur at random point of time and space, wherein our interest lies only in the number of occurrence of that event, not in its non-occurrence. So just to give you some context that what I have just narrated, I am going to talk about some of the examples. So following are some of the instances. I am listing them just to get a sense of it, that when we can apply the Poisson distribution. So following are some of the instances where Poisson distribution can be used, right? Can be used. So number of deaths from a disease such as heart attack or cancer or due to snake bite. So for example, if I talk about that, if you have a data, previous year data, and you know that in a certain city, suppose because of heart attack, on average 200 people die, right? Now it may be asked that what is the probability that this year 300 people may die because of heart attack. So when I am saying 300 people may die because of heart attack, I am not restricting the I am here, listen this very carefully because this may be slightly confusing. What I am saying is that suppose I say on average 200 people die every year because of heart attack in a certain city, right? Now someone may be interested in knowing that what is the probability that 300 people may die. So the number of people dying because of heart attack may vary from what? It may vary from 0 to one indefinitely large number, right? Because it is possible that next year no one may die because of heart attack, or one person may die because of heart attack, or two-person may die because of heart attack. And it is also possible that lot of people, indefinitely large number of people, may die because of heart attack. And this is what the point I was trying to make here, that here the number of trials may be indefinitely large number of people may die because of heart attack, right? So the random variable x can take value 0, 1, 2 up to infinity. Up to infinity, theoretically, some of you may argue that if in a city finite number of people are living, that how can infinitely large number of people may die. But I hope you have understand the context here, that the number of people dying because of heart attack may take value from 0 to a large number of possibility. Similarly, the number of suicide reported in a particular city. So we noticed that and in the recent news we have heard about the city quota. So on average, suppose 20 students or 20 people are committing suicide in a particular year, right? And suppose the data is there for maybe 20 years. Now someone may be interested that what is the probability that only 10 people will commit suicide next year because certain awareness campaign has been launched, or what is the probability that 100 people may die because of the heart attack or because of the suicide, right? So the number of people dying because of the suicide may vary from 0, 1, 2 up to an indefinitely large number of people, right? So that is why the random variable can take indefinitely large number of value. I hope you are getting it. I am spending a lot of time on this idea. Similarly, if you talk about the number of printing mistake at each page of the book, so here there may be a 0 mistake, there may be 1 mistake, there may be 2 mistake, or there may be a very large number of mistakes. So in all these cases we are interested in finding the number of mistakes. Means we are if I say that finding a mistake is a success for me, so I am looking at the success, I am not looking at failure, because if I am not finding a mistake, that is of no concern to us, right? So proceeding forward, let us take some example to understand this better. So the first example that I am going to solve is this very popular example, and here it is saying that a car hire firm has 2 cars, right, which it hires out day by day. The number of demand for a car on each day is distributed as Poisson variate with mean 1.5. Means the most important thing is to look for mean, because that is the parameter, and in the problem they already have provided that lambda is equal to 1.5. We have to calculate the proportion of days on which neither car is used and the proportion of days on which some demand is refused. So before I solve this problem, I hope you understand this, that suppose you are running a car rental agency and you have only 2 cars, then neither hiring out a car is a success for you. Yes, because if you are running an agency, you want to make money, so hiring out a car is a success for you. But sometimes it may happen that you are sitting idle throughout the day and no demand was there, right? So no demand is there means neither car is used, both the cars are lying in the parking space, means no car has been hired out. So what is the probability of that? And on average it is given that 1.5 cars are demanded on a particular day. Now here you also need to understand that 1.5 car may not be possible, like, because this is the average value. Average means that on a day suppose 1 car is demanded, on other day 3 cars are demanded, on some day no car may be demanded. So on average 1.5 cars are demanded. So neither car is used, so it means that on that day we want to calculate the probability for 0 number of success, means no car is being used. And we have just seen that in case of Poisson distribution, the probability of x number of success is given by e to the power minus lambda to the power x by factorial x. So if I have to calculate for 0 number of success, I will write e to the power minus lambda is minus 1.5 into 1.5 to the power 0, because x value here is 0, and divided by factorial 0. So 1.5 to the power 0 is 1, and factorial 0 also we know is equal to 1. So what we got here is e to the power minus 1.5. And if you have the calculator, you can evaluate this using the calculator, and the value that you will get is 0.2231. I hope you know how to calculate this thing using the calculator. Now let us talk about next part, that proportion of days on which some demand is refused. Means proportion means that I think out of 1 day, 0.22 day or 0.2231 day, means on average. On proportion means, I hope, see, sometimes in probability question, if they say that 5% chances, means the probability is how much? Probability is 5 by 100. Suppose the proportion is 0.2231, so means what is the probability? Probability is 0.2231, right? Means the probability is very small. Similarly, if they ask you what is the proportion of days on which some demand is refused, so ladies and gentlemen, when the demand will be refused, if you have two cars and if there is no demand, then how can you refuse the demand? If there is a demand of one car, then you will hire out one car. You can't refuse the demand unless and until you are mad. Second possibility is that there may be demand of two cars. In that case also you can't refuse it, because you are running an agency. You will refuse the demand only when the demand is there for more than two cars, because in your agency you have only two cars. So when they are asking proportion of days on which some demand is refused, and I hope you also understand this very clearly, that the demand may be of any number of cars. There may be a rally of some political leader, so there may be huge demand. There may be some marriage function, right? And there may be huge demand. So demand can be refused. In it is the situation, means we are going to calculate the probability for the number of demand x is greater than 2, and x greater than 2 may be anything. X greater than 2 may be probability for x is equal to 3 plus probability of x is equal to 4 plus probability for x is equal to 5, and so on. It is up to infinity. Right, theoretically it is possible that the demand may be of infinitely many number of cars or indefinitely large number of cars. So calculating all this probability is going to be a very difficult thing. So what we are going to do, we can use our common sense, and we know that the sum of probability is equal to 1. So from this I will subtract the probability for demand of 0 car plus probability for demand of 1 car plus probability for demand of 2 cars. Right, gentlemen and ladies as well. So this is equal to what? This is 1 minus probability for x is equal to 0. So let me change the ink. I am starting from here because I want to make maximum use of the space. So e to the power lambda, so e to the power lambda is e to the power minus 1.5 into 1.5 to the power 0 by factorial 0. Probability for x is equal to 1, so again e to the power lambda, that is e to the power minus 1.5 and 1.5 to the power 1 by factorial 1, and for x is equal to 2, e to the power lambda, that is minus 1.5 into 1.5 to the power 2 and divided by factorial 2. So to simplify it, what we can do, we can take e1 minus e to the power 1.5 can be taken common, and this will be like 1, right? And this will be 1.5 and this will be 1.5 square by factorial 2. So if you simplify this expression, the value that you will be getting is 0.19126. I would suggest you to verify if you have a calculator. It will also help you to understand that how the calculator should be used appropriately, right? So this is the probability or the proportion of days on which some demand is refused. Before I go to the next problem, I just also want to highlight one more thing, because I made a comment that sum of probability is equal to 1, and we also told you that if you talk about the probability mass function or probability distribution, in case of Poisson distribution, it is e to the power lambda e to the power minus lambda, lambda to the power x by factorial x, and x can take the value from 0 to infinity, indefinitely large number of value. So we have seen, when I was discussing about discrete probability distribution, I have told you that and this is also a discrete probability distribution, by the way. This is also an important point, that Poisson distribution is a discrete probability distribution. So the property was that probability of x should be greater than or equal to 0, and the second property we talked about was the sum of probability should also be equal to 1. So these two were the properties of the discrete probability distribution, and since Poisson distribution is also a discrete probability distribution, these two properties should be true. So it is obviously true if you take e to the power minus lambda. We know that exponential functions are always positive, so this term will always be positive, and lambda mean will be positive, right? So this probability of x is certainly greater than or equal to 0. But the second thing I want to show, because I have used this and I wanted you to understand, if you take the summation of e to the power minus lambda, lambda to the power x by factorial x, and if you take the summation from 0 to infinity, you should get 1. So let's see we are getting 1 or not. So here e to the power minus lambda is a constant, it is independent of x, so we can take it out of the summation. And in the summation we have x from 0 to infinity, lambda to the power x by factorial x. So we can write what? We can write e to the power minus lambda, and if we take x is equal to 0, I will get lambda to the power 0, that is 1 by factorial 0, so I will get 1, right? If I take x is equal to x is equal to 1, I will get lambda to the power 1 by factorial 1. If I take x is equal to 2, I will get lambda to the power 2 by factorial 2, and so on. So I hope you are all aware that this is nothing but this bracket is nothing but e to the power lambda, the exponential series expansion. I hope you all remember that e to the power x is 1 plus x by factorial 1 plus x square by factorial 2, and so on. So if you see, if you add this thing, you will get e to the power minus lambda plus lambda, right? So this will become e to the power 0, so this is equal to 1. So the sum of probability is equal to 1. So that is something that I wanted to verify. Okay, let us move to the next question quickly. So in this question it is given that in a certain industrial facility accidents occur infrequently, right? It is and that is the situation B. When the accident happens very frequently, that is not a nice situation. Yes or no? So it is given that accident occur infrequently. It is known that the probability of an accident on any given day is 0.005. So the information that is available with us, that probability of an accident is 0.005, and accidents are independent of each other, right? First part of the question is, what is the probability that in any given period of 400 days, means we are looking at the number of trials, 400 number of trials, means for solving the first part, n is equal to 400, right? And probability is equal to 0.005. So on average, if you look at a period of 400 days, how many accidents are expected, and that can be calculated by the mean lambda. So lambda is given by n into p. So n into p is 400 into it can be written in the fraction form like 5 by 1000. Yes or no? So you can cancel this, and you can cancel 2 and 4 and 2, so you will get what is equal to this is equal to 2. So lambda is equal to 2 means what? Did you understand this? Lambda is equal to 2 means that if you look at a period of 400 days, on average 2 accidents will happen in a period of 400 days, right? This is the average number of accidents happening in a period of 400 days. But the question that they are asking, that what is the probability that in any given period of 400 days there will be an accident. They just want the probability of one accident on one day. So means they are asking the probability for one accident. So as per the formula, what is the formula? E to the power minus lambda. I write it here. I'm writing it again so that you at least can see that how the probability is calculated. So e to the power minus lambda. So e to the power minus lambda is minus 2 into lambda. So lambda is 2. X value I want to take 1. So by to the power 1 and by factorial 1. So what we get? We get 2 into e to the power minus 2 and e to the power minus 2. So if you calculate this value, how much will you get? So actually if you use the calculator to calculate the value of e to the power minus 2, it will be 2 into, and the value is equal to 0.1353. So I just calculated this, and that is 0.2706. That is the probability. See, in case if you don't have the calculator, I mean ideally you should have that because it requires the use of calculator. But in case if you don't have, you can leave your answer like 2 into e to the power minus 2. Right. Now let us go to the next part, B part. What is the probability that there are at most 3 days with an accident? Now for the same thing, they are asking us to calculate the probability that there are at most 3 days. So what is the required probability in that case? At most 3 days means we want to calculate the probability of 0 accident on a particular day. What is the probability that there are at most 3 days with an accident? So I am first calculating the probability of 0 days with an accident, then probability for 1 day with an accident, then probability for 2 days with an accident, and then probability for 3 days with an accident. At most, right? If I say that you are required to bring at most 3 rasgullas, so it means what? That you are not expected to bring 4 rasgullas. Either you bring no rasgulla, 1 rasgulla, 2 rasgulla, or 3 rasgulla, right? Sometimes you go to your market with your father as a young kid, and they say that at most you have to eat 3 samosas, right? So you can say that I don't want to eat, or you can say I will eat 1 samosa or 2 samosa or 3 samosa, but it is already said that you are expected to eat at most 3, so you can't eat the 4 samosa. Samosa and rasgulla example, I hope you understood it. Anyway, so let us proceed further. Now what is probability for 0 number of success? So e to the power minus lambda. So e to the power minus lambda, lambda we already have calculated, e to the power minus 2 into 2 to the power 0 by factorial 0, right? Plus probability for 1 success, so e to the power minus 2, 2 to the power 1 by factorial 1, plus for this is for 1 number of success. For 2 number of success, e to the power minus 2 and lambda to the power x means 2 to the power 2 by factorial 2, then e to the power minus 2, and then 2 to the power 3 by factorial 3. So if you simplify, you can do the simplification. E to the power minus 2 will be common, and 2 to the power 0 by factorial 0, so this will be basically 1 plus 2 by factorial 1, so it will be 2 plus it is 2 squared, so 4 by factorial 2. So 4 by factorial 2 is how much? 4 by 2 is 2, and this is how much? This is 2 to the power 3 is 8 and factorial 3 is 6, so this will be 4 by 3. So if you do this calculation, what will be the value that you will get? I'm going to do the calculation and then I'm going to write it. Okay, so the value that I have got by doing the calculation is 0.856. so this is the required probability. I hope you are following it. Do some more problem. Now if I look at this question, I think red ink looks better. Red is hot. A manufacturer of cotter pins knows that 5% of his product is defective. If he sells cotter pins in a boxes of 100 and guarantees that not more than 10 pins will be defective, what is the approximate probability that a box will fail to meet the guaranteed quality? Ladies and gentlemen, first in the box, how many pins are there? 100 pins. So the number of pins are 100. And how many pins are expected to be defective? The probability, that is 5%, means 5 by 100. So what is the lambda? Lambda is n into p, that is 100 into 5 by 100, which is equal to 5. So I hope you have developed the sense here that if you are putting the pins in a box of 100, on average you may expect that there will be 5 pins which will be defective, right? It means what? That sometimes it may also happen that no pin may be defective. Sometimes it may also happen that 20 pins may be defective. Getting my point or not? Because if you have boxes in which you have put the 100 pins, on average, because of your experience in this sector, you know that on average our machine is creating 5% defective product, right? But when you sell it and when you give the guarantee, you are saying that if you buy a box of pin, I can guarantee that not more than 10 pins will be defective. Because if you just guarantee of 5, then every it is likely that lot of your boxes will fail to meet the guaranteed quality. So you want to play safe, and you are saying that in any box not more than 10 pins will be defective, right? So basically you want to calculate the probability, that what is the probability, and the question is what is the approximate probability that a box will fail to meet the guaranteed quality. So suppose a customer comes and he buys a box of quarter pins, then when he will come back to you with the guarantee or card that your box has failed to meet the guaranteed, when in the box more than 10 pins will be defective, because in the guarantee you already have mentioned that not more than 10 pins will be defective. So up to 10 pins the customer can't claim the guarantee, right? The customer can claim the guarantee only when more than 10 pins, means if x is greater than 10 is true, right? So we have to calculate the probability for x is greater than 10, and x is greater than 10, so x can take all the values from up to 100, right? X may be 11, x may be 12, x may be 13, x may be 14, up to 100, because in the box there are 100 pins. And we have told you that in Poisson distribution the number of success may vary from 0 to indefinitely large number, and large numbers means we are not sure that up to what extent it will have the defective number of pin. So calculating the probability for all those values for x ranging from 11 to 100 is a difficult thing. But we also know that the sum of probability is equal to 1, and I have shown you that as well. So what we can do, we can calculate 1 minus probability for x less than or equal to 10. Yes or no? So 1 minus probability for x less than or equal to 10. What is the probability for x is equal to x? Probability for x is equal to x is e to the power minus lambda, lambda to the power x by factorial x. So basically I have to calculate the probability for x is equal to 0 plus x is equal to 1 up to probability for x is equal to 10, right? So it can be written in the form of summation. I can write 1 minus and summation e to the power minus lambda, lambda to the power x by factorial x, and I have to calculate for x is equal to 0, so I will start the summation at 0. Then I will take x is equal to 1, x is equal to 2, up to x is equal to 10, so I will take the summation up to x is equal to 10, right? So what I got 1 minus e to the power minus lambda, so that I can and this is e to the power minus lambda term is independent of x, so I can take it out, and lambda is 5, so I can write e to the power minus 5, and here I will have summation lambda to the power x by factorial x. X is varying from 0 to 10, right? Now this is a calculation that I have to do, right? So as such if we have the time and energy, I will do it. Otherwise I can leave our answer like this also, or one more thing I can write, because lambda is known, so let me rewrite it. E to the power minus 5 summation x varying from 0 to 10, and lambda is 5, so 5 to the power x by factorial x. So I need to calculate this part for 0, 1, 2 and up to 10, and then take the summation. But I am leaving it as such, and you can also, if they ask this in the exam or they are not providing any other information, then we can leave the answer up to this also, because calculating all the values will be very time consuming. Okay, fine. So let me do one more problem, and I think this problem should be the last one. So in a book of 520 pages, 390 typographical errors occur. Assuming Poisson law for the number of errors per page, find that a random sample of 5 pages will contain no error. And I have asked this question to a student multiple times, and I have seen that they make mistake in solving this question, and I will highlight here, and you can also possibly make a mistake, so you can pause the video and try to solve it and see that where you are making the mistake. But I am going to continue, right? So first of all, here it is said that in a book of 520 pages, 390 typographical errors occur. So what kind of information that they are providing? They are providing the information that on average how many errors occur on a page. There are total 520 page, and in total there are 390 typographical errors. So on average on a single page we can expect 390 by 520, that is 3 by 4, which is equal to 0.7 errors per page, right? On average. I hope you are getting it. I am highlighting this on average. So the lambda value is 0.75, and they already have told that it is following the Poisson law for the number of errors per page. Now the question is, find the probability that a random sample of 5 page will contain no error. We want no error. So here the mistake is that a student start considering this as n. No. First what we are going to do, we are going to calculate the probability for 0 error or no error on one particular page. If I am selecting one page randomly, what is the probability that it will have 0 error? So probability distribution is given by e to the power minus lambda to the power x by factorial s. So it will be e to the power minus 0.75 and then again 0.75 to the power 0 and by factorial 0. I write all these terms so that you don't get confused. Otherwise I could have written directly e to the power minus 0.75. So this value that I have got is the value of what? Value of the probability for 0 number of error on a page, because the lambda that I have got, it is what? It is the number of errors on average on a page. Lambda is what? It is the number of typographical error on average on a single page. So the probability that a single page will contain 0 error will be e to the power minus 0.75. Now you are selecting 5 pages randomly. So it means that selection of these pages are independent. Whether the error will first page has an error, it is not going to affect that whether the second page has an error or not, right? So it means that if I have to calculate the required probability that in a random sample of 5 pages there should be no error, so for that we are going to multiply this probability of no error on a single page 5 times. I hope you understand this, that when you perform 2 independent events, the probability of that is probability of first event into the probability of second event. So it means that if I am selecting one page and I am getting the probability for 0 number of success is this, then on 5 page I need to multiply this probability 5 times. So this will be probability of x is equal to 0 to the power 5, which is in turn e to the power minus 0.75 to the power 5. So which we can write as e to the power minus 3.75. You can leave the answer this like this or use calculator to answer it, right? So here I hope you have understood that what I have done, I have calculated the probability of 0 number of error on a single page, and then since I am taking the 5 pages sample randomly, I have calculated the required probability that those 5 pages that I am selecting randomly will have no error. So for that I have multiplied the probability of no error on a single page 5 times, and what I am getting is equal to this. Okay, so this is all in this video, right? I would request you to share it with all your friends who are taking the course, and also like the video, right? And the link of the previous videos and the playlist I have given you in the description below, so you can check that as well. Watch the videos in the sequential order. In the next video I am going to talk about the moment generating function, and that will be a long video, because in that in the single video I'll be talking about moment generating function of binomial, Poisson, negative binomial, and geometric distribution, because that will cover the content of more than 2 lectures, more than 2 hours of lecture, or even more, right? So it will be like a long video. So wait for that, and thank you for watching.